All right, homework 4 here deals with problems in section 1.4, which concerns circles, the equations associated with circles and their graphs. So we've got two fairly similar problems here, 26 and 33, which are sisters to the assigned problems 25 and 29, I believe. So let's just take on 26 pretty quickly. 26 gives this equation, 3x plus 1 squared plus 3y minus 1 squared is equal to 6. And it says, let's find the center and the radius of the circle described by this particular equation. And in order to do this, I think you have to remember that the standard form for a circle is x minus h squared plus y minus k squared is equal to r squared. And in this case, the center then is the ordered pair hk, and the radius is this quantity r. So what's left for us to do is just transform this equation in 26 into this form. And you can see it really doesn't take a lot to do that. If I divide through each term on both sides of the equation by 3, then I'll get very far along that way. If I divide through by 3 here, this 3 essentially disappears. 3 over 3 is 1, and I'm left with x plus 1 squared, plus likewise this 3 disappears, y minus 1 squared, and then 6 divided by 3 is 2, but I'm going to write that root 2 squared, and I'm doing that because now I just need to compare this transformed equation to the standard form. And I can see that if x minus h is x plus 1, then that only happens if h is equal to minus 1. And if y minus k is equal to y minus 1, that happens if k is equal to 1. That says that the center is the ordered pair minus 1, 1. And if r squared is root 2 squared, then r must be equal to root 2, and that says the radius is root 2. Okay. So a little bit more work to do in the second of these two problems, problem 33, because the equation that's given is a little further away from the canonical standard form. So let's look at 33. 33, I'm just now copying it down, is 2x squared plus 2y squared minus 12x plus 8y minus 24 is equal to 0. I'm trying to be professional here, but I got to let my dog go out the back door here. I've got to hurry and finish the problem now. I'm going to have to let her back in. So you've done this enough times that I think you recognize that what has to happen is we're going to complete the square for both the x terms and the y terms. And in order to do that, I'm just going to first of all just sort of group them, pull them close together. I'm going to put the 12 minus 12x close to the 2x squared, and I'm going to put the 2y squared and the 8y together. And then I'm going to take the minus 24 and just slide it to the other side of the equation. And now separately complete the square for both of these group sets of variables. And remember, in order to complete the square, you really have to have a coefficient equal to 1 on the leading or quadratic terms. So in order to get that, I'm going to factor 2 out of both of these terms. I'm going to effectively wind up completing the square inside these parentheses. In fact, I'm going to change these parentheses here just so we can keep track of them. And likewise, take a 2 out of these two terms, giving me y squared plus 4y. I really haven't done anything else at this point, but just pull the 2's out so that I can go inside the square brackets now and complete the square. So in order to do that, in this case, I'm going to divide that minus 6 by 2 to get minus 3. I'm going to square it to get 9, and I'm going to add 9 and immediately turn around and subtract 9. So I haven't really changed these two equations by adding and subtracting 9. I've effectively added 0. I'm going to do the same thing here. In this case, dividing 4 by 2 to to get 2, squaring that to get 4, adding a 4, and subtracting a 4. All right, so the next step collapses these first 3 terms, recognizing that they are a perfect square, and rewriting them as x minus 3 quantity squared. I'm just going to carry along the minus 9 for a second. I'm going to do the same thing here, recognizing these 3 terms are y plus 2 quantity squared equals 24. And now I'm just going to distribute the 2's back across these various terms and take care of these constant terms here. So I'm going to get 2 times x minus 3 squared, and 2 times minus 9 is minus 18 on the left-hand side. That turns into a plus 18 on the right-hand side. Do the same thing here. 2 times the quantity y plus 2 squared. 2 times minus 4 is minus 8 on the left-hand side is plus 8 on the right-hand side. And so there's my equation. And in fact, if I do this arithmetic, 24 plus 18 is 42 plus 8 is 50. And now to achieve standard form, all I've got to do is divide all the way through by 2. X minus 3 squared plus y plus 2 squared is equal to 25, and 25 is 5 squared. And so now by inspection, I'm going to see this x minus 3 plus y plus 2 as x minus h squared plus y minus k squared, and I'm going to just write down that the center is the ordered pair 3 minus 2, and that the radius is 5. 1 dog, 1 cat, and we're done.